In this problem we'll see how we can get two possible triangles when given two lengths and a non-included angle, and using the sine rule. So first we have triangle ABC. So we'll draw and label. We have angle A, and length A is across from our angle. Now length C is across from angle C, which is down here, and angle C is 30 degrees. So in this case I want to find angle A. So using the sine rule, I'd have the sine of A divided by the length opposite, which is 10, is equal to the sine of 30 divided by the length opposite it, which is 6. So rearrange the equation, we'll get sine A equals 10 sine 30 divided by 6, which we can enter into the calculator, and we get an answer of 516, or 0.83 recurring. Now to work out angle A, we will take the inverse sine of 516, or 0.83 recurring, and we will get an answer off the calculator of 56.44 degrees. So that's the value down here for angle A, but we need to consider another possibility, that is a supplementary angle. So we could have angle A being 180, take 56.44, which gives us an answer of 123.56 degrees. Now, is that answer possible? This angle here, if it were 123, if we add it to 30, we get 153, which means we do have another possible value for angle B. So from this point we need to do two sets of calculations. So one for when A is 56.44, and the other when A equals 123.56. So let's start with the smaller of the two. So if we have A is 56.44, then if I want to work out angle B, then I know that the sum of the angles in the triangle is equal to 180. So I'll add up angles A and C together and subtract that from 180. So I've got 180, take away 56.44 plus the 30 degrees. So we get a value for B of 93.56 degrees. So now I need to work out the length of B in my triangle. So we have the sine rule. We have B divided by the sine of angle B, which in this case is 93.56, is equal to any other ratio you choose. I'm going to choose the ratio using the values provided, that is the 6 and the sine of 30. So we can rearrange that equation there to get that expression. Once again, on the calculator, we can find that value. So we've got 6 sine of the value of 93.557, etc., divided by the sine of 30, and we get an answer of 11.98 rounded off. So that's one of the possible triangles. So we have angle is the acute angle, length B to work out is an obtuse angle, and we have length B here. Right, let's do it for the other value of A, the obtuse angle. Alright, so we have A is 153, oops, look at that, 123, sorry. Alright, so now if I want to work out the value of angle B now, then once again, B would equal 180 degrees, subtract A plus C. So we've had 180, take away 123.56 plus the 30. And that gives us 26.44 degrees. Okay, so now working out length B. Once again, we'll do length B over sine of angle B, which is now 2644, and use the ratio given once again of 6 divided by sine of 30. So B would equal 6 times the sine of 2644 divided by the sine of 30, which would give us an approximate value. So we have a length of 5.34. So our second triangle, let's just tidy things up a bit. So there it is. We have two answers for angle A, one acute, one obtuse. They're supplementary pairs. We then also have two answers for angle B and two answers for length B. So we can have two different triangles given a length of A, a length of C, and a non-included angle of 30 degrees.